Hello there, my dear students. How was your day? I really hope you were able to cope up with our previous lesson. This is still Miss I, your teacher for today, and I welcome you all to General Physics 1. Our lesson for today is about component form of the vectors in 2 dimensions, and this is still anchored according to the DEPED's most essential learning competencies for week 1, which is to rewrite a vector in component form. At the end of this video lesson, you should be able to solve the vector components of the given vector in 2 dimensions.
So last time, we already have discussed about the addition of vectors using the analytical methods. So this is just a continuation to that, because for today's lesson, we are going to add vectors, again using analytical method, the same as the last video lesson. Okay, so let us have a recall first that the sum of the 2 vectors in 2 dimension can be solved using the following equations. So we already have introduced these equations to you last previous video. Okay, so your resultant vector is equivalent to the square root of your rx square plus ry square, and to get the angle is to use this formula, tangent theta is equal to ry divided by rx. Okay, where your rx here is the sum of all the vectors in the x components, and your ry is the sum of all the vectors in the y components. So you have rx equals to ax plus bx and so on, and then your ry is equals to ay plus b. So for solving the magnitude, so this is how we did last time, right? Your x and y components are separately added. Okay, so you have here, if you have two vectors, ax, you have ay, then you have bx, by. So the a here corresponds for the given vectors. So your first vector is a, your second vector is b. So you just use the formula here for x component. It's a cosine theta and b cosine theta. For the y component here, we have ay, a sine theta, by, b sine theta. So we have used that last time. Then we continue until the last vector. So last time we only have up to 2 vectors. Okay, so that's why we have only a and b. So again, we have to take note that the angle of the vector should be read counterclockwise from the 0 degree. So in solving for the magnitude, we are going to add all the x and the y components using this equation. So we did this last time. And to calculate the magnitude of the resultant vector, we use this. Your bold letter R that's the resultant. Okay, and to solve the angle, substitute the value of the equations 3 and 4 into 2. So tangent theta is ry rx over rx, where your rx and ry is the sum, okay, of the vectors. Then we take the inverse tangent of the function. Now, to get the component form of the vectors in 2 dimensions, first, the vector r projected in the Cartesian plane as shown below. So for example, we have here, okay, look at this. We have 2 vectors rx, and you have also your ry. Okay, so this one here at the center is your resultant. Okay, vector r. So you have 2 vectors rx and ry. That's your vector r. This is your angle. This part here is your angle. Okay, now your theta, that's a Greek letter theta. Your theta here is an angle read counterclockwise. So when we say counterclockwise, it should be from the 0 degree. This is your 0 degree here. That's your 0 degree. Counterclockwise. So you moved it this way. Okay, let's so this one here, and then okay, that's counterclockwise. That is your theta. Okay, that's how you read your theta. It must be read counterclockwise from the 0 degree. So the component form of the vector can be written as Rxi, that's R equals Rxi plus Ryj, where your Rx is the R cosine theta and your Ry is the R sine theta. So remember that what we did last time, we still have to get the cosine and the sine. For Rx, it's still cosine. For Ry, it is still your sine. We're going to solve the components of x and y of the vector using the equations 2 and 3, and take note, angle should be read counterclockwise. Your Rx is equivalent to R cosine theta and your Ry is R sine theta. Substitute the value in step A to equation 1. So whatever is your answer here, you're going to put it here. Okay? So your answer here, your answer here, and your answer here, you put it here. Okay, then you just copy the I and J. So let's have an example. So a vector R, 5 centimeters with angle of 30 degrees in the Cartesian plane. What is the component form of the vector? That's 30 degrees. Okay, so here is our diagram to that, or our illustration. You have your Rx here and your Ry, you don't know, right? That's why it's question mark, because you're only given the resultant. So last time in our previous example, we are given the two Rx and Ry, but we are going to need, or we are solving for the resultant. This time we're given the resultant and we need to get the Rx and Ry. So how are we going to do this? So this is the angle here. The angle is given, it's 30 degrees. That's the diagram again. So solve the components x and y of the vector using the equations. Okay, what was our equation? Rx equals R cosine theta. So the R is 5 cm, that's given here, times cosine 30. You copy cos 30. Okay, then the answer is, in your scientific calculator, cosine 30 is 0.866. Therefore, 5 times 0.866 is 4.33. Next, for your Ry, then you only need to multiply also the given R times the sine theta. So 5 cm times sine 30. Again, the 30 here is given from here. So 5 times 0.5, because sine 30 is 0.5. So it will give you 2.5. Therefore, we're going to substitute the values from our Rx and Ry. Okay, so we already have solved Rx and Ry. We just have to substitute that. So your Rx is this and your Ry is 2.5. Then the component vector is this formula. So we just have to substitute that. So you have your R, 4.33 from here, cm, and then you just write the italic I, letter I, plus your 2.5, which is here, 2.5 cm, then J, italicized. So that's how we get our component forms. So we're now given the R, and we're going to solve for the Ry and Rx. Previously, we are given the Ry and Rx, and then we need to solve for the resultant. Okay, so that's it.
Thank you so much for watching, my dear students. I hope you're all good now. Can you solve now the vector components of the given vector including MELC-Based? If you have any questions, please don't hesitate to message me on my social media accounts as you see flash on the screen. See you on my next video lesson. Until then, bye for now!